So hemostasis, also sometimes spelt with an A before the E if you're looking, so this is how the Americans spell it. Hemostasis is the cessation of bleeding, and that's the prime role for platelets, and it consists of 3 phases. We're going to look more at these 3 phases now. So the 3 phases that you need to remember are the vascular phase, the platelet phase, and the coagulation phase. So the vascular phase is triggered immediately after the injury has occurred. So think of a cut on your finger. So the cut triggers a vascular response, and this vascular phase lasts for about 30 minutes. There are 3 steps to the vascular phase. We have the endothelial cells contracting and exposing the basement membrane to the bloodstream. Here is the vascular phase. So here we've got the knife cutting through the blood vessel, and the vascular phase, just as it says, causes vasoconstriction, and the endothelial cells become sticky and adhere to platelets and allow platelets to adhere to one another. The next phase is the platelet phase, which begins 15 seconds after the injury, and this is where platelets will aggregate together and they'll stick together. They will stick to the endothelial surface, to the basement membrane, and to the exposed collagen fibers of the cut edges. And that will form the primary platelet plug, which will help to close off and stop the blood loss. So what we're looking at here is that we can see the diagram. You've got the orange area up above, and that's representing inside of the blood vessel. Then you've got the pink area with the cells, that's actually the vessel wall, and then below that you've got the interstitial fluid. Alright, so that just gives you an orientation as to what you're looking at. So it says that the platelet phase of hemostasis begins with the attachment of platelets to the sticky endothelial surfaces, to the basement membrane, and to the exposed collagen fibers. As they become activated, the platelets will release a variety of chemicals which promote more platelets to come together, further vascular spasm, and clotting and vessel repair. So the coagulation phase is the 3rd phase, and this begins 30 seconds after the injury. And so blood clotting is called coagulation, and there is a cascade of reaction called the clotting cascade, which now begins to occur. This is a chain reaction of enzymes and proenzymes which form 3 distinct pathways, and they convert circulating fibrinogen into insoluble fibrin, and the clot is formed. So let's look at these 3 pathways. So here is the clotting cascade. You can see that with the Roman numerals, the factors down the left-hand side, that there are 13 factors. You're not expected to know all of these factors, but there are pathways that you will need to know. You can see here over on the far right hand side that different factors are involved at different parts of the pathway. So we're going to go through that pathway now. The coagulation pathway, it has 3 components. It has the extrinsic pathway, the intrinsic pathway, and the common pathway. So the extrinsic pathway begins in the vessel wall, so the actual wall of the blood vessel outside of the bloodstream. So think of extrinsic, exit, outside of the bloodstream. And we get damaged cells releasing what is called tissue factor. This combines with other compounds and I'm getting a bit tongue-tied here, tissue factor plus other compounds equals an enzyme complex, and it activates factor 10 of that clotting cascade. The intrinsic pathway begins inside the bloodstream, and it begins with the circulating proenzymes found within the bloodstream, and it's activated by enzymes by collagen. So the platelets release factors, and a series of reactions activate factor 10. Then both the extrinsic and the intrinsic pathways converge at factor 10, and then you have what is called the common pathway. At the common pathway, that forms an enzyme called prothrombinase, and this converts prothrombin to thrombin, and thrombin converts fibrinogen to fibrin, and this is how we get our clot forming. So let's look at this. It looks a very complex drawing, but we can break it down. So let's get ourselves orientated again. So what we're looking at is we're looking at the yellow part of the drawing, which is inside the blood vessel. We've got the cells, the pinky bits, and the layers, which are the actual vessel. And below that, you've got the intercellular fluid. So we've got the vessel, which has been damaged. In the middle of the drawing, you can see the platelets are there. And we have the three pathways. So on the far left, you've got the extrinsic pathway, and that starts down in the vessel wall where you've got tissue damage. You can see there the arrow then points up to tissue factor 3 plus calcium plus clotting factor 7 forms tissue factor complex, and that joins the common pathway at factor 10. Next one, we have the intrinsic pathway on the far right hand side, and this comes from the platelets from within the bloodstream, and we get the platelet factor, P factor 3 plus calcium, and the clotting factors 8 and 9, and they help to activate clotting factor 10. Now, both the extrinsic pathway and the intrinsic pathway meet in what is called the common pathway, which is the big blue arrow, at factor 10. At factor 10, what happens is that you get the conversion of prothrombinase into prothrombin, which then changes into thrombin, which converts fibrinogen into fibrin. And you can see those little blue lines. Those little blue lines are fibrin, which is insoluble, and that helps to firm up the clot and make sure that it will stay where it is and plug and not allow any more blood flow to leak out of it. To the far right hand side, you can see red blood cells caught up in this fibrin network, which is formed to which is a blood clot. So hemostasis, as we said, is reliant upon calcium ions. It's also reliant on vitamin K for blood clotting. So they're very essential for blood clotting. So clot retraction is the final stage of the coagulation bit, and this occurs when the torn edges of the vessel are drawn closer together so that you actually get the vessel trying to unite itself, and it reduces the size of the damaged area. And it makes it easier for the fibrocytes and the smooth muscle cells and the endothelial cells to complete the repairs because there's a smaller gap to fill. So this is the last slide, and again it's taken from your books. You can see that clot retraction, just reiterating what I said, once the fibrin meshwork has formed, the platelets and the red blood cells stick to the fibrin strands. The platelets then contract and the entire blood clot begins to undergo clot retraction, a process that continues over between 30 minutes and an hour. Bye for now.